Good day, people. This is Anthony here. And today we will be talking about data validation. So, for those who have seen the API that was written during the network automation course, I don't know of all of you guys who've seen it, but in essence, when you create the requests, you need a way to verify that the data that is input to the API, if you're doing a post or a put, you need to validate some way that that data is actually along the lines of what it is you want the API to take and do something with. So you're probably wondering, what context do you mean by that? What kind of validators would you want to use on this type of data? And what would the result look like? So, firstly, before we get into that, I want to cover specifically the lab devices data. Now, this data is used on the back end of the API to store your device inventory information in a YAML file, and then whenever you call the API will talk to the YAML file. It'll take that data and it will present it to the user that's using the API. So if we were to look at a single entry here and how this entry is laid out, you're going to see that there's specific fields here that you probably only want specific types of information in. So one of those examples could be our network OS. We only want certain network OSs to be allowed when we add a new network device. Whether that be iOS, could be EOS, could be iOS XE, could be NXOS. And you have a list where you have a set of enumeration values for that field. Another thing we could consider is not so much in this case, but in some data structures, you're going to have things like, for example, you're going to have Booleans. You're going to have integers, or maybe you'll have float values, or even maybe you want a very specific regex pattern to identify. Another thing you could consider is IP addresses. You could consider MAC addresses. These are all things that should be looked at within the inputs before the API actually takes the data and does something with it. So there's a couple ways to do this. You could actually write it into the code, and I'm going to show you what I mean by that. So we have a couple things here that you'll see. We have a get devices method. We have a get device method. Under the get devices method, we have a get and a post option. Okay? So one thing that we could do is we could add some form of validation manually ourselves. One way we do that is we could have, let's say, a network OS's list. Within that list, we put in all the various network OSs that we want to allow. Okay. So after we do that, then what we would do is we would have some way of verifying whether any of these are within a part of the request. Okay, so there's a couple of validation methods in here already. One of them is if the length of the request is not equal to 9, then we return a 400 message, a 400 response code. If you look at over here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 fields specifically. Okay. The next thing is we need to consider each of those individual fields and the type of data that's being passed into that field. So if we are to do that, what I'm going to do first, let's ignore this because this is what I want to cover. This is the more dynamic method of validating your data. We're going to do a more manual one with this data here. And we're going to say if request.json, and the JSON will be in a dictionary format so we can access a dictionary field. We'll say NOS, not in NOS's, return JSONify error and then we'll say network OS not valid, and then we return a 400 response code. And actually there's an error here. This should have a error key at the beginning of it, otherwise if we get down to this, it's going to throw an error within the code. So then what would happen is if we were to try and add a new entry to our API, and I want to actually start the API first, so I'm going to run this. And it will start. Okay. Next, what we're going to do is we're going to add switch 1 as a post to the API. What we are going to do is we're going to change our network OS to something that's not in those options. We're going to say AOS. We're going to submit the request. And we get an error. One, two, three, four, 5, 6, 7, 8, 9. Except we're getting a more generic error here. And it's because what's supposed to happen is we're supposed to delete that part. This is our endpoint if you see here. So we're going to rerun that. And as you can see, we now have a return message, network OS not valid. All right. So this is exactly what we built in by design. This is what we expected. Now, the thing is, though, about this message, it's not very intuitive because the person using this API is not going to know what the valid OSs are. Okay? So we're going to add something into here, into this error message. We're going to turn this into an F string real quick. And we're going to say valid network OSs. We're going to add in here our variable, and it's going to be a list comprehension. Within that list comprehension, we're just going to say X for X and network OSs. So it'll just print all the network OSs that are presented in this list. And then we're going to rerun that, and it gives us a list of the various network OSs that we can put into the API. Okay? So that is more of a manual input method, a validation method. And the thing is, you're going to have to put one for every single possible permutation that you can think of. Okay, so let's go back to this data and think about this for a second. What are some other possible things you could put here? Maybe there's only a set of regions that you want to allow in the region field. Maybe there's only a set of roles that you want in the role field. Same with the sites. Maybe you only want to allow IP version 4 addresses in the TACX server field. Maybe you only want to allow specific vendors into the vendor field. And then device name, of course, has to be a string. So you'd have to validate all these things. Firstly, you'd have to validate the type. And then if you have a set of enumeration values, you'd have to validate that. And then if we were to split these two into a management IP and a management prefix or sitter block or subnet mask, then we would need a integer for this field. Okay? So these are all the things that you would have to write conditional clauses for to verify that they actually work. And if we go over to config policies is quite a bit more open because a lot of this we would just define as a string. And then device types, again, we could probably have some kind of enum values for that. It seems all kind of tedious, doesn't it? It seems very tedious to write out all these various conditionals. We don't want to have to write this into the code. What we want to do is we just need to define a schema somewhere, and if the input does not conform to that schema, then we need to throw an error. It needs to be simple like that. So the question is, what do we use to do that? Before I jump over there, let me remove this conditional clause I just threw into here. And let me re-enable this one because this is the one we're actually using. And I'm going to show you something called Cerberus. Cerberus is a data validation library. It's lightweight. It's not super complex, but it's got a lot of various features that become extremely useful when we're trying to do something like creating an API with some form of data validation. So I'm going to go over this very briefly. You have to first define a schema. Within that schema, there's going to be various parameters that you set. One of them being, what is the data type? Is it a string? Is it an integer? Is it a Boolean? Is it a float? A dictionary? A list? Okay? And then after that happens, there's going to be a object you have to create called the validator class from Cerberus, and it will validate the data that is being input into your API. This is very, very simple at a high level, and you can read this documentation to the degree that you desire. But there's some really, really nice little tools in here you can leverage. One thing is the length. Maybe you want to limit the length of the value that is being put into parts of the data input. Okay. There are other things. Minimum being if it's an integer, it has to be at this minimum. So this would be useful if you have like a VLAN and you want to set a max of 4094 or 4095. Then there's other things that are useful to have as well. One of them being the errors method here. Errors will return any errors you receive where the data was not valid, based on the schema provided. Okay. So I'm going to try and show you some more advanced examples here. The allowed field is good when you want to set some enumeration values. So like I said earlier, iOS, EOS, and XOS. If you have this for a field, this is where you would put it. This is where you put it. So that's very useful as well. Now, there are some various other things in here that we are going to cover briefly, but I just wanted to give you a very prime, basic example of what this thing can do. It's really, really nice, and it's really easy to learn, okay? So we're going to go back to PyCharm for a second, and I'm going to show you one of these schema definitions, okay? You can take your schema definition and you can define it in a YAML file, and that's what I did here. So each of these fields, as you can see, these are all from our API, management IP, model, network OS, region, okay? You're going to see various things here. First one is the type. You already know what the type is. Second one is required. So required. So this is another nice thing, is sometimes when you make an API call and you are providing inputs, there's going to be some inputs that aren't mandatory. Some people may not put a description, even though they should, but it's not mandatory. Some people may not require other pieces of metadata. In this case, I'd say most of these are probably required. The only thing I did not require here was a TACAC server. That's pretty much it. I was just doing that to show nuance. And then, as you saw, allowed, here's your enumeration values. That's very simple. Finally, you will see something here you may have not noticed before, which is IPv4 address. So you're probably wondering, I didn't know this was data type. This is a really nice thing about Cerberus. You can define custom data types. So what you're probably wondering is where and how is this data type defined? So what I did, and this is from some code that was written and modified by someone else, these few custom validators here. You can find this all on GitHub. I did write a couple of the ones in here that are new. The device types and the platform both are custom validators. We will get to that in a minute. But what I did is whenever you call, so typically you call, as you saw in the documentation, you typically call the validator, okay? The validator is the base class, the base object for Cerberus. Well, what you can do is you can inherit all the properties of the base validator and define a custom validator and inherit all those base attributes. So then under the custom validator, you define your custom data types. And you will say underscore validate underscore type underscore and then the name of your new data type. So in this case, we have IPv4 address, IPv6 address, and we have MAC address. And if you come back to lab devices, you will see, the validator file, YAML file, you will see it aligns 100% with this. But you have to make sure that it starts with validate underscore type underscore. That's the most important part. And then what it does is, here it imports the IP address library. And there is a class in the IP address library to where you can verify if it's an IPv4 address, if it's an IPv6 address, or if it's a actually the MAC address is just a regex definition. The other two, they import the library, they call this function here, which verifies if it's a IPv4, IPv6 instance, and then it returns a value based on that. So that's a really nice thing that is built in here. Now the next and last piece has to do with custom validation pieces. okay? Which, if you look at the extending Cerberus page, what you'll see is there's a way that you can apply some extensibility to a particular field. So what this does is you can essentially return a custom value or a custom message, and that's really what I'm doing here. Because the base message that's used for device types and for platform within this base class of Cerberus is unfortunately not as comprehensive as I'd like it to be. So what I do is, you'll see here, it says for device type and value, if device type not in schema allowed, and as you recall, this is where that's coming from, then it returns a message of, here's your valid values, okay? Because what would have happened if I wouldn't have done that is it would have just said, this is an incorrect value. It's somewhat brief. Now, for the things that are not enumeration values, it's not a problem. But for the pieces that have set values, it's good to have this custom validator here. So, you're probably wondering, where does this come in the code? Okay. What you are going to see is right here. What has to be done is first the YAML file is loaded, and then after the YAML file, and this is the validator file, after the validator file is loaded, you have to define the methods for the specific validators being used under a specific field, okay? Because remember, in a YAML file, your value or your key value pairs are going to be a specific data type. They're going to be, again, a string, an integer, a Boolean. You can't pass a function name into a YAML file. It's going to read it as a standard data type. So what you have to do is you have to load the YAML file first, and then you have to add on to the schema that's used with your particular function, okay? So that's pretty much that. Now, you're probably wondering, what does this look like? Okay, so this is already running. What I'm going to do again is I'm going to run this exact same thing as I did before. And for some reason, it looks like it actually took the data. And I'm wondering why. Because AOS is not valid. Oh. I take that back. There is no enum value set for this. So, since that's the case, what I'm going to do now is you get to see how we build this piece out here. But before I do that, what I'm going to do firstly is I'm going to remove switch 1 from here. So we do not want that. I don't think it actually restarted my API, so let's stop this and restart it. Okay, so we're going to change this. So that one is good. There is an enum value for a vendor, so we're going to set the vendor to something that is not valid, like Cisco's. There we go. Unallowed value syscos. The thing is, what you may have noticed here is if we go back to our validators, this was specifically written for our config policy validators. Okay? It was not written for our lab devices validators. So we get to write a new validator here. We want to have a set value for our vendor, and we want to have a set value for our network OS. In this case, I'm just going to show you one so you kind of understand how it ties together. Okay? So the first thing that we want to do is we need to have a set of allowed values here. So we're going to say iOS, EOS, iOS XE, iOS XR, NX OS, Junos, and I'll leave it at that for now. I'll leave it at that. We're going to restart the API. Okay. I'm going to come back here. And again, we're going to say AOS. Unallowed value syscos, unallowed value AOS. So not only, see, this is the thing about writing manual conditionals on the app itself. It's only going to show you the invalid data that shows up first. So if you have multiple invalid fields, it's only going to show the first one that it sees. Whereas with Cerberus, Cerberus is going to tell you every single invalid value when you get a return. Okay? But in the other thing is here, what you see is only that it's unallowed. There's nothing here that says this is the valid set of values that you can use. So the way that we do that is we have to come back over here. And we have to add to this. We have to add some custom validators. Okay? So we have a file defined and we have a set of custom validators defined. We are going to write our new set of custom validators. But before I do that, I want to make sure this looks fairly formatted. So the first one was what? It was vendor. Okay. Now, just make sure that this aligns with how the fields are defined here, which you're going to see most of these are capitalized, not all of them are. And technically I could probably apply like a lower or an upper transform onto these data fields, but I'm not going to in this case. But we're going to say vendor, and then actually we're not going to say vendor, we're going to do network OS first. Say network OS, and we're going to say validate NOS. That's it. Okay. And validate NOS is not defined. So because that is the case, it's going to kick us off here. Now what will happen if I actually write this in and say validate NOS verbatim to what's down here, then we shouldn't have a problem. And the field value error, that's all generic stuff that comes into the extenders. All right. So then we're going to copy this in here. We have to change this validator to our lab devices validators. Okay. And then we're just going to keep the return message identical. Okay. I'm going to restart this. And there you go. Now it's running. No more errors. Okay. So, now that we have that in place, I want to make sure all this lines up. And it looks like it does. So we're going to rerun this. We're going to delete this for now. We're going to send. And looky there. We now have a set of what the valid values are for our network OS. Now I'm going to do that for the vendor as well. I want to do that for the vendor. We're going to validate vendor. We're just going to copy this. And actually, that's pretty much what we want. So then we're just going to add another key value here. We're going to say vendor, validate vendor. Okay. And that's it. Now let's rerun this, and we're going to add an invalid value here too. And now we have a much more comprehensive definition of what is expected in these input fields. It's as simple as that. It's as simple as that. Let's look at the code for a second, okay? So what's going to happen is you're going to see this validate schema here. This is like our base function. If you look at the API itself, I'm going to delete this as well. We don't need this anymore. You're going to see something that says invalid schema, validate schema, the request.json, which is the input from the user whenever they make the post. And then we pass in what is the API service. So we have lab devices and we have the config policies API sections. So what's returned within the validate schema is our errors. And all we're saying here is we're saying if invalid schema, which basically means if an error exists, then we're going to return that error, and we have to load JSON because it's serialized. And then we return our 400 code. Now, one thing that Cerberus does not do is it's not going to validate the length of your request. So that's really the only thing that I can think of off the top of my head. That's really the only thing that's going to need to be validated within the code here and come back with some type of error for that. But everything else can be validated here. Okay? So, probably wondering how this works. All right, so let's look at the mapping table. All right, so it says for num mapping and enumerate mapping table. So we're enumerating over the entries in mapping table here. Okay? And then num just comes from our enumeration, which means it's going to be 0, 1, 2, 3, 4, 5. Okay? It's just an iteration method. And then it says if mapping.get validator. So what is validator? Okay, let's come back here. Lab devices is our validator. All right. Lab devices exists here. Okay. So in that case, what that means is that there are custom validators being used for that part of the API. Then what we do is we load our schema file, our data validation file. Okay. After that is loaded, then we say for field, comma, my validator in mapping table, num, validator, custom validators. Okay, so items. So let's go through this real quick. Okay, filled my validator in mapping table. Here's our mapping table. Num, again, this is where the enumeration value comes in. Okay. And as you'll see here, we are mapping, since it's a list, this is how we identify where it is in the list. This is our position. This is what the num's for. Okay. And then we have to go through the key values within the dictionary. So we're saying validator, it's the name of the validator, which is in this case lab devices. Okay. So now we're in here. Okay. And then we say custom validators. We go to the custom validators. Dot items. Okay. So field in my validator is NOS, validate NOS, and vendor, validate vendor. And then we're saying schema file. Okay, we loaded the schema file in here. Okay, let's look at our schema file. All right, schema file field. What is the field name? Where does the field name come from? The field name comes from here. Okay, so we're going to look at NOS. Okay, and then what is next? Validator. Okay, so this is a new key because it's not in here. As I told you, we cannot keep this stored in a YAML file. It's not gonna recognize things as objects. It'll see them as a string. It'll see them as an integer. It'll see them as a float. It'll see them as a dictionary, a list. It's not going to see it as it'll not take it as a function. Okay. So then we define our new field within that particular data input with our new validator. Our my validator comes from the value of NOS, which is validate NOS, or validate vendor for our vendor. And that is what we're doing. We're taking the YAML file, we're converting that into our object, which would be a list of dictionaries. And then we're calling the validator, okay, the custom validator. And we could add more stuff into our custom validator and add more data types, custom data types. And then we say v.validate, and then we call our data, and the data comes from here. Okay, what is our data? Request.json is our data. That's the data that's being input into the API. And then we call the schema file. And the schema file is the one that's validating the data. After that, you're not going to get an error. Assuming that your schema file exists, assuming that your data exists, it's not going to throw anything. But if there are errors, then we say if errors, return json.dumps v.errors. Now, if you didn't include this conditional here, what's going to happen is when you try and return this, it's going to throw an error. Okay? Because if v.errors doesn't exist, then it's going to throw an error. Hopefully that makes sense. So that's the whole thing. That's the whole thing. That's pretty much all you need to know about Cerberus. Very simple, very straightforward. I think it's really nice. It's a super nice way of doing data validation. You can put this into any project you have and it will work. And once you have these data validators written up, once you've written them for yourself, then most of it's going to be copy and paste. After you have a set of validators for network automation, or whatever you use it for, most of these custom data types and custom validators, you're just going to be copying and pasting a lot of this. It's going to be super simple. You're not writing all these conditionals. All you're doing is writing the schema file, defining the custom validators as needed, and then putting that into wherever you want to apply the data validation. Okay? So that is that. That's all there is. That's all there is for today. Now, if you enjoyed this video, what I want you to do is I want you to like it firstly. Share it if you enjoyed it, and if you think other people would benefit from learning about this. Spread the word. Get it out there. Because these little things being put into your code can be extremely beneficial when you're automating within your network, especially if someone is using this that is not familiar with the tool, so maybe they don't necessarily know what they're supposed to put in as the input. You got to guide them on that. Obviously, documentation can help too, but let's be honest here. Not everybody reads documentation the first time around until they know that they need to know something specific. They read just enough of the documentation to get started. Okay? That is all I have for today. The next videos that will be coming out, you will be seeing some more practical stuff. We are going to do a couple videos on device inventory. But before we do the device inventory, I want to introduce you to regex. Because when you do device inventory is going to involve and require knowing your regular expressions to get the inventory data in the appropriate format that you want. Okay? Regex, network inventory part 1, network inventory part 2. All right? Thanks, guys.